All right, today we are diving deep into a really fascinating new AI paper that could seriously change the game for image creation. It's called UMO, and it's designed to tackle one of the most stubborn problems in AI image customization. Let's get right into it.
So here's our roadmap. We're going to start by unpacking the core challenge of customization and get a handle on a major hurdle called identity confusion. Then we'll introduce the UMO framework as the big solution, break down exactly how it works, look at the test results, and then wrap up by talking about why this thing is setting a new state-of-the-art in the field.
Okay, so let's set the stage. The promise of AI image generation is, absolutely incredible. But the more ambitious the tech gets, the bigger the challenges become.
And right at the heart of all this is something called image customization. This is the magic where you can give an AI, say, just a few photos of a person, and teach it to create totally new images of that exact same person in any situation you can dream up. It's an incredibly powerful tool, but it has one glaring weak spot.
The problem really rears its head when you try to customize an image with more than one person. See, current methods, they just struggle. They fall into this trap the researchers call identity confusion, and it's where the AI literally mashes up the faces of different people into one. The goal, of course, is the opposite, to have each person look exactly like themselves, consistently, every single time. So this brings us to our next big point. We really have to drill down and, from a more academic perspective, define this core problem of identity confusion. So what are we actually talking about here? What does this term really mean when we're looking at these diffusion models? As the paper lays it out, identity confusion is when the model just fails to keep individual identities straight when it's generating an image with multiple people. So instead of getting two distinct faces, you get this weird blended hybrid. And this has been a massive roadblock, really limiting how far these models can scale. So why does this even happen? Well, the paper points to a few key culprits. First, these AI models are just incredibly sensitive to human faces, which can actually cause them to get confused and mix up features. Second, the problem gets exponentially worse the more people you add. And finally, the old ways of doing this just had built-in limitations that made this problem kinda unavoidable. But that is where our hero, the UMO framework, enters the picture. The researchers have proposed a really elegant solution. UMO stands for Unified Multi-Identity Optimization, and its entire mission, its whole purpose, is to solve this one problem. To maintain super high-fidelity identities, get rid of that nasty identity confusion, and do it all in a way that can scale up to handle more and more people in a single shot. So the big question is, how does it actually do it? Let's pop the hood and take a look at the really clever mechanics that make UMO so powerful. The process is actually quite brilliant. First, it uses what's called a multi-to-multi matching approach, which is all about making sure every single reference face is correctly paired up with a generated face. Then, it cleverly reframes the whole challenge as a global assignment optimization problem. And finally, it uses reinforcement learning to basically reward the AI for getting it right, training it over time to nail the consistency every time. Now, that term, global assignment optimization, I know it sounds a little intimidating and abstract. So here's a really simple way to think about it. Imagine a wedding planner. They've got 100 guests and 10 specific tables. Their job is to make sure every single guest ends up at exactly the right table. No mistakes, no mix-ups. Well, UMO is doing that same thing, but it's doing it with facial features and identities. It's a super complex matching game, and UMO solves it perfectly. Of course, having a great idea is one thing, but you have to prove it actually works, right? So let's dig into how the researchers validated this framework and what they discovered. And what's really cool is that in this paper, the authors didn't just give us a solution. They actually made 3 distinct, really significant contributions to the entire field of AI image generation. Okay, first and most obviously is the UMO framework itself. This isn't just a small improvement. It's a genuinely new way to get multi-identity consistency, and it's a method you can apply right on top of models that already exist. Second, you can't solve a problem if you don't have the right data to test it. So they built a brand new, scalable dataset that mixes synthetic and real images. All of it designed specifically to push this multi-identity problem to its limits. This dataset alone is a huge gift to the whole research community. And third, and this is so critical for the actual science, they created a new metric to measure identity confusion.
This is huge because it lets us move beyond just saying, it looks a little weird. Now, researchers can use hard data to score how well a model is doing and compare different methods objectively. And this chart just lays out the results perfectly. When they used their new metric to put UMO head-to-head with the old methods, the winner was crystal clear. While the older techniques were plagued with a high degree of identity confusion, UMO just crushed it. The confusion was reduced so significantly, it represents a massive leap forward. So when you put all this work together, it leads to a very, very clear conclusion about UMO's place in the AI world. And honestly, I think the paper's own abstract says it best. The authors write that their experiments prove UMO's superiority and that it is, and I'm quoting here, setting a new state of the art. That is a powerful, powerful claim, and they've got all the research to back it up. So, if you remember one thing, it should be this. UMO isn't just some new standalone model. It's a foundational framework. It's a general solution that you can basically plug into other customization methods to make them way better, more consistent, and more scalable. It just raises the entire bar for everyone. And all of this leaves us with one final, really exciting question to think about. We've just watched a major technical barrier come crashing down. So now that AI can reliably handle multiple, distinct people in the same image, what does that unlock? What new creative, collaborative, and storytelling doors have just been blown wide open? The possibilities are really, really exciting to think about. Thanks for joining me.